static pressure, but understanding that using that as a tool is going to be one of the greatest things that you'll gain from a zoning system. The good is, because you're going to be pushing the air harder, you're going to have greater static pressure, you're going to have better velocity and throw from the registers, you're going to reduce destratification in the room. So in other words, there's a lot of second floor bedrooms when this AC system is running, you have to stoop pretty low to tell whether the AC is running or not, because the air is just kind of barely coming out of the register. The increased static pressure is going to give you that velocity and throw to shower the ceilings and the walls and get that air moving and stop that. Everybody know what destratification is? Cold air at the bottom, hot air at the top. That's just what physics want to do. The increased static pressure is going to help mix that. Decreased BTU duct loss. So the longer it takes to get the air from your equipment to the area that is calling, the more BTU loss you're going to have. The faster we get it there, the more BTUs you're going to retain and actually deliver it to the area that you want. You're going to satisfy the zones quicker, and then you're going to get more BTUs into those hard-to-reach areas. Now the negatives could be if you have a lot of duct leakage and you increase static pressure, you're going to have a lot more duct leakage. One way to know that is if it's the middle of summer and it's 93 degrees and humid outside and you're in the basement and you want to go grab your hoodie out of the van because it's so cold down there, they have duct leakage. So be mindful of that. If you push the static pressure too high, you're going to have objectionable air noise, which we talked about. And then if you really overdo it, you're going to be pretty hard on your customer's equipment, and we don't want to do that. Now when it comes to bypass, we're just going from supply to return to shut off some of that excess static pressure. Those are the two options we offer. Here's kind of what that ModuPass looks like. This transmitter is looking at the internal pressure inside of the ductwork. The Arzel panel is supplying pressure to this damper and holding it closed because our static pressure is low right now. If the static pressure increases in the supply duct, this is going to start purging pressure off of this line. The panel is still trying to provide pressure to the line. This is a restrictor metering how fast it can be replenished. This starts to bleed that off, and the spring starts to modulate the damper open, and it goes into bypass mode. Bypass location, if your mechanical room is barely bigger in the closet and you can only put it on the back of the equipment or something to that effect where it's coming off the plenum directly to the return, that's fine. It's not ideal, but if that's the only place you can put it, it's acceptable. We prefer to see them maybe 6-8 foot down line. That way the supply air coming out of here goes into the return but has more time to be diluted with other return air before going immediately back through the equipment. So while this is fine, this has less time to get diluted before going through that cycle versus a little further down the line offers more tempering to that air. That doesn't mean putting it all the way down here is a great idea. So if at the equipment's fine, but 6 or 8 foot down is better, don't assume that putting it all the way at the very end is even better. We have seen instances where people have put it at the end, and then we end up forcing more supply air into the return than what it can bring back, and we've turned return air grills in the hallway into supply vents. The Arzel bypass calculator, you should have one of those. So if you look at that bypass calculator, there's a few things I want to point out. One side is marked in the green circle at the top right. It says trunk damper or branch damper. There is a separate calculation for trunk dampering, and so there's a different calculation based on whether you're doing a trunk damper or a branch damper system. At the bottom of the card, the bottom like half or whatever, it says other bypass sizing considerations. If you're using the calculator and you're unsure or you're kind of on the fence on whether I need an 8 or a 10 or I need one or I don't need one, the other bypass sizing considerations making you look at different factors of your system. Is there flex duct? If you have flex duct acts almost like a sound attenuator, and it reduces airflow and has higher frictional loss, and it's going to eat up potentially some of your velocity and your air noise. If you're dealing with a distant zone, on the opposite end of the house of the equipment on the second floor, and I have great distances to get there, then I might not need a bypass, or I might be able to go down a size. On the flip side, if my smallest zone that I'm doing a calculation for is a close zone, or maybe it's not flex and it's hard metal pipe and it's a closed zone. So in other words, I'm doing a calculation for my smallest zone being the primary bedroom, and it happens to be right above the mechanical equipment, and my supply runs are only 4 to 5 foot long and they're solid metal pipe. I don't have very much time or frictional loss to eat up velocities or air noise. I might have to go up a size in a bypass. Or if I'm on the borderline and I'm not sure if I need one or not, might want to plan on figuring in a bypass because my smallest zone's right above the equipment. Special purpose zone, that's another factor you have to take into consideration. Now, just to do a quick calculation here, go to your trunk damper side of the bypass calculator, and then what we're going to do is we're going to take a 300 CFM zone with a 3-ton system, and then what size bypass do you need? 8 inch. Now, what if my 300 CFM zone was other end of the house and it was all flex to get there? What I suggest is figure it, quote it, order it, get it to the job, but don't install it till you commission the system and see if it's objectionably loud. And your customer should be the one to determine if it's too loud. There's a thing we refer to as the sound of comfort, and it comes from, like, there's been jobs that I've done where it's like I commission the system and I go to that primary bedroom and it's like, wow, you can really hear the air coming out of those registers now. And I take the customer there and I'm like, I'm assuming this is probably too loud, all that air noise coming out of there. Like, I can put the bypass in and I can cut that back for you so it's not so loud. And they're like, are you kidding me? Like, I've lived in this house 10 years and he came and adjusted the blower speed, he cleaned my coil and he adjusted dampers and all this, and like, I've never heard air coming out of here. Like, and now I can hear it? Like, why would I want you to do anything to take that away from me? That sounds like comfort coming out of there. So let the customer determine whether it's objectionably loud or not. Now flip it over and go to branch damper side. Do the same calculation, 300 CFM, 3-ton system. Yeah, branch damper should be the asterisk, which is borderline, which tells you down here, the asterisk borderline case, check other bypass sizing considerations, that's down here. If it's a distance zone, flex zone, you're definitely not going to need one. If it's very short, it's hard metal pipe, and it's the bedroom right above the equipment, you might want to figure out one. Now the modupass comes in 3 sizes, 8, 10, 12. I call it small, medium, and large. 8 is our most common. 10 we sell a few of, 12 we sell very, very little of. For me, I kind of use it also as a barometer. If you do a bypass calculation and you need a 12, might be more of an indication you should go back to the drawing board and see if you can make that zone a little bit bigger. Why am I using the biggest modupass our zone makes residentially? It's probably because I created a really small zone on a fairly large piece of equipment. I should probably try and get more supplies on there or make that zone bigger. If I need a 10, it's probably okay. If I need an 8, you know what, that's totally fine. A little bypass is not a bad thing. While a lot of our systems, especially if they're multi-stage and it's on the Heat Pump Pro, don't need a bypass at all. If all you need on your system is an 8 inch, yeah, that's fine. That's not very much bypass at all. When I have a branch damper system, I have the plenum, I have my trunk going under each way, I have part of the takeoffs, and then I have a damper. And the blower can build a static pressure up in that and kind of settle down. When I do trunk dampers, where are the dampers usually at? Right at the plenum.
Right.
And so now I slam the door here, slam the door here, and slam the door there, and I have this plenum and these takeoffs, and the air is bouncing all over, and I get all these weird currents, and it's a much noisier system to try and deal with. And we found that you need more bypass when you do a trunk damper system to try and account for that, to quiet the system down. Branch damper systems, the blower can build a nice static pressure throughout the system, and it just makes a more stable system. If you have a combination, I got like 50-50, err on the side of caution, just treat it like a trunk damper system. End of the day, if you have any questions on this at all, you can just call us. Here's what I got, here's what I designed, do you think I need a bypass or not? So typical bypass sizing, what we didn't realize till we worked with National Comfort Institute is your average bypass moves air at almost 2,000 foot per minute. Well, back in the 80s when we were sizing bypasses, we were treating them like a supply run. So getting pushed from the blower out through the coil and into the system and treating it like a branch run. But if you think about a bypass, it's usually this 3 to 4 foot section of pipe connected to basically a high pressure and a low pressure, and it's getting shoved in one end and sucked out the other. So when we were sizing bypasses back in the day, we were thinking, yeah, we're probably getting about this much airflow. We were getting far more air through bypasses than what we thought. Our average bypass that we sell is the 8-inch. It can move somewhere around 750 to 800 CFM of air, max. Most are not moving that, but we were floored to find out through testing with professionals that this kind of velocity was being. Now, that's the average. We saw sometimes 1,500, we saw as high as almost 2,500 foot per minute velocity. But that would take a very small damper and steal a lot of valuable airflow and static pressure if you didn't adjust it correctly. When you're sizing your system based off that calculator, you need the tonnage of your air conditioning, you need to know whether you're doing trunk or branch dampers, and then you need to know the design CFM of your smallest zone, or how many supplies are in there. With those 3 pieces of information, you guys can most any calculation. And like I said, you're always welcome to call us for any questions you have, or just to do the calculation for you. You don't have to use the calculator if you don't want. Bypass setup, the first thing I recommend is confirm with your customer, is this zone noisy? And if they say yes it is, then you install the bypass. Once you install the bypass, you're going to start with the bypass in the closed position, and you're going to have your customer go into that zone, and you're going to say, I'm going to go adjust the bypass incrementally and open it a little at a time. And what I need you to do is to let me know when the noise level in this zone is acceptable. Whether you got them on the phone, whether they're going to stomp on the floor, whatever your method of communication is, you're going to use the customer. You're going to make those small adjustments to start opening the bypass. Once the bypass is open enough to resolve the air noise issues and your customer gets you on the phone and says, that's it, that's good, or stomping on the floor, that's your adjustment. I want to maintain the highest permissible static pressure in the system as I can, with as little airflow going back into the return as possible. That air going back into your return is taking the load off your coils, taking the load off your heat exchanger. That air going into your return, if you dump too much of it into the return, that's when you're going to start tripping limits. That's when you're going to start freezing the coil. That's when you're going to start slugging back to the compressor. Who's done an AC startup when it's like 60 outside and only like 65 inside? That's what you don't want the bypass to do to your system, is to dump so many BTUs into your return that you get this snowball effect where it just starts getting so cold or so hot that we start short cycling the equipment, we start being abusive, that kind of thing. So that's why I want you to maintain as high of a static as you can with as little bypass going into the return as possible. That's the ideal setup.